Welcome to Brain Vision.
Okay, so for this question, we have three things. One is our Earth, one is the Moon, and one is the satellite. Right? So in order to find the net force from Moon and Earth applying on satellite, the easiest way to find is to find where is the center of the mass of Earth and the Moon. Suppose this point is the center of the mass. So the distance between this point and Earth is d, right? So suppose this point is 0, is at position 0. So the d times the total mass, so the position of center of mass times total mass is equal to the position of the Earth, which is at the origin 0, times the mass of the Earth, plus the position of the Moon, which is L. L is the length of the triangle side, times the mass of the Moon. From this equation, we can solve that the distance d, the position of the center of the mass, is equal to 4.67 times 10 to the 6 meters. And from this triangle, I show it here, we know this side is d, this side is L. We need to find what's the distance between the satellite and the center of mass, which is a small l here. So we know this angle is 60 degrees, so we can use this equation. Okay, is this equation L squared equal to d squared plus this side square is equal to this side d squared plus this side L squared minus 2 times d times L times cosine this angle, which is 60 degrees. And solve this equation, we can find the L, the distance from the satellite to the center of mass, is 3.82 times 10 to the 8 meters. Now we know the distance, we know the mass, we can find the force by using the gravitational force equation. The gravitational constant times the mass of the satellite times the total mass from Earth and the Moon divided by the distance from the satellite to the Earth Moon center of mass, L squared, okay? And the value is 3.4 Newton. Since we know the distance dl and small l in this triangle, so we can easily find that the angle theta here is around 0.61 degree. So that's the direction of our force. So for question B, this is for question A. For question B, so we need to move the satellite to some infinite point. So at infinite point, the potential, the final potential is 0. And the initial potential is the potential we have when the satellite is here, right? So the work is the final potential minus the initial potential. So basically it's negative initial potential, which is g mass of satellite times the total mass of Earth and the Moon divided by L, small l, and the value is 1.31 times 10 to the 9 joules.